Same idea with 7 through 10. So basically, quote unquote homework, but as you know, it's not like I'm going to check it or anything. It's just we'll go over it and so on. We'll do this proof on page 11, number 11 on page 5, and then we'll take a break, and then I have a little group activity for you to work on. All right, but this is our first foray into the 2-column concept of a proof and how to properly structure it. Coming out of spring break, and it's so weird to think of it as spring break. I mean, although I am wearing shorts, so I guess it's fine. Coming out of spring break, we're going to do, like I said, that exploratory activity where we learn where all those rules, the SAS and stuff like that, come from. So it wouldn't make sense to go too crazy with these proofs right now, because if you don't have the proper grounding and like why things work the way they do, it wouldn't really make too much sense. So today's activity is really just going to be more along the lines of drawing conclusions, like what we did on that one page where it was, what can you conclude and why? All right. So statements and reasons is it's a reasonable way of structuring your proof. It's an organizational strategy that people tend to stick to because it allows you to clearly state what conclusion you're drawing based on the given information and why those conclusions are being drawn. Right? So the first thing we do is we take our given information and we use that to mark up our diagram. So we mark the living daylights out of it because having a nice diagram is the key to understanding what's going on geometrically. Right? Triangle ABC, okay, cool. You never know. It might not be a triangle if it's an incomplete figure or something like that. It's confirming that it's definitely a triangle with AC congruent to BC. All right, so I'm going to mark that up. 1 tick mark for each of them. All right, so once I've accounted for a piece of information, I include it as a statement. So triangle ABC with AC congruent to BC. All right, that's a piece of given information. I don't have to justify it using anything more elaborate than that. I take a look to see if I could, it's like Wheel of Fortune. Like, can I solve the puzzle? Right? Am I at the point where I can get to the proof statement? Can I now state, okay, I got my given piece of information. Can I now say those 2 triangles are congruent? No, I need to buy a vowel or something. So D is the midpoint of AB. Okay, so let's work off of that. If D is the midpoint of AB, that means these 2 bad boys are congruent. So I'll make a note. My second statement is D is the midpoint, abbreviations are fine, of AB. Again, it's a given. But we can draw a conclusion from this because this statement here doesn't talk about congruence. All right. This helped me mark that up, but just kind of on the fly, we drew a conclusion that those 2 line segments are congruent. But we never stated it in our proof. So that has to come. So this is still along the same thread. I would say AD is congruent to BD or DB, either way. Now you just need a reason for it. Right? So you just think about, well, what caused you to draw the conclusion to begin with? Well, it was because D was the midpoint of AB that we said that those 2 line segments are congruent. Right? So odds are your reason is going to be definition of something. Right? Well, we have it. Definition of midpoint. All right. So then, again, Wheel of Fortune approach, you're looking at it like, can I solve the puzzle? Not quite. So we spin the wheel. Well, we have no more givens, so now I'm just going to look at the picture. Fortunately, this is very similar to what we were just talking about. I do have that line segment CD that I know has to be congruent to itself. So CD is congruent to CD, and that's the reflexive property. And so, well, we've covered all the sides. We haven't addressed any of the angles, but that's okay. Because one of our postulates that allows for proving triangles to be congruent to one another is if each set of corresponding sides are congruent. So this one's congruent to that, this one's congruent to that, and this one's congruent to that. Then the two triangles are themselves congruent to each other. So I can now solve the puzzle. Triangle ACD is in fact congruent to triangle BCD, and that would be by the SSS axiom. All right, so we tackled number 11 first. And so, we're just going to kind of go back and grab these homework problems. So directions state what additional information is needed to prove the triangles are congruent using the given justification, then write a congruency statement. All right, so I need SSS. So it should be pretty easy to see based off of the information that we have and what we need. SSS, I need 3 pairs of corresponding congruent sides. So in order for that to work out, this side would have to be congruent to this side. All right, so my additional information required would be that XV, side XV, must be congruent to side AC. All right, now I'm going from the direction of X to V here, and you'll notice that that's from the direction of the side with 2 tick marks. All right, so here's the side with 2 tick marks, so that's telling me that I want to go from A to C. All right, so A to C. In terms of naming it, we want to have that consistency. Ideally, am I going to take off if you don't? No. But, just in an ideal world, this is how we would do things. All right. So if I'm naming my triangles, I would do my best to name it using that convention. So I would say the triangle XVW would be congruent to ACB. So if I wanted to, I could name, let's say, for example, I wanted to name the second triangle ABC. Then I would name the other triangle XWV, all right, because I would want to follow that same pattern. All right, AAS, all right, so AAS, now this one wasn't talked about on the previous page. This is 2 angles, but the side is not in between them. All right, so then you kind of play it around and you see, well, is there any way that I could designate 2 other angles being congruent and accidentally have that side in between them? It doesn't look like it, because if I put this second angle here, the side is not in between them. The side would have to be here in order for that to play out. All right. If I wanted to, I could put the angle here and it would work also, because again, in order for it to play out with the angle side angle, the side would have to be in between those 2 angles, and that is not the case. All right, so I'm going to go with angle angle X congruent. The triangles have the same orientation, so it's pretty, I think, easy to see that angle X and angle F are the 2 ones that are corresponding to one another, and therefore the ones that we would need to be congruent. All right. And so naming should also be pretty easy, because I could say X, Y, W, and then just follow that same pattern around the triangle FEG. All right. The next one's a parallelogram. And, there's a lot of useful pieces of information when it comes to a parallelogram. The first two triangles were disjointed, or first two examples had triangles that were disjointed. These two are connected. There's some logical things that we could actually assume here. Like, for example, and we don't have to actually justify them yet, still. That's what the proofs are for. But we could state that GH is congruent to GH. That would be by the reflexive property, but again, it's not something that we need to state. We also need one other piece of information, because again, if it's AAS, I need a second angle. All right, so we're looking at a parallelogram, and a parallelogram is just basically a larger example of two parallel lines that are cut by a transversal. If two parallel lines are cut by a transversal, then your alternate interior angles would be congruent. All right, so I have a lot of different possibilities here. The ones that I'm going to choose to select would be these two. All right. As long as the two angles I select are not surrounding the side, the pair of corresponding congruent sides, then I'm fine. And there's no way that that could happen based on the given angle, so I'm in good shape. All right. So this would be RGH, angle RGH, would have to be congruent to FHG. All right. Now those are angles in their respective triangles, so I could actually name the triangles the same way: RGH, FHG. All right. For ASA axiom, additional information. Well, I need a side, and I need two congruent angles, two corresponding congruent angles. So I can grab my vertical angles here, because we know vertical angles are congruent. Even though I don't have to state the reason, it's nice to know at this point. JKL congruent to RKP, assuming that's a P. All right, now I just need a side. Oh, I should put two arcs on those. Now, if it's going to be ASA, the sides, the relevant sides, would have to be the ones in between those two angles. All right, so JK would have to be congruent to RK. Now, again, because JKL are angles within the same triangle, JKL and RKP, those could also be the name of the triangle. So JKL, RKP. And there it is.